Hey everyone, in this video we're going to take a look at a project where I move a function from Blueprint over into C++. So you can see here that we have this actor in the world that's spawning these bombs at random locations at a radius. We're going to take a look at how we make this, the logic that does this in Blueprints. You can take a look at here. We have a blueprint function that does this, and then we move the logic of the blueprint function over to C++. It's not a lot of code, but the purpose of this video is to show the process rather than actually explain in detail what we're doing. And we end the video off on showing how we can extend the C++ implementation and do some interesting things for debugging. For example, here we have this show debug points option on the bomb dispatcher actor. We have a distance from center value that we can change. So if we put that to 2000, we can see that the bombs are being spawned anywhere between the location and the 1000 2000 range. So let's just jump into it and get started. So we'll start by making a new Unreal project. This is a C++ project that I created. It includes the starter content. So let's begin by making some of the actors that we need for this to set up. So I'm starting out just making an actor. I'm going to call it BP bomb dispatcher, and I'm going to make another one and calling this BP bomb. And the blueprint logic that I'm going to make is I'm going to go here into the bomb dispatcher. I'll open it up here. Let's see. Like so. Okay. I am going to start by making it spawn these bombs that we're going to have. And the way I'm going to do it is I'm going to do set timer by event. So every, let's say, 0.2 seconds, this is going to call a custom event called spawn. It's going to call a function that we're going to make, and I'm going to do, the function is going to be called get complex bomb location, and this is the function that we're going to be moving over to C++ later. So starting out, we're going to do get actor location. We are going to create a random unit vector, and we are going to multiply the random unit vector with a number, let's say 500 on all axes here. We're going to add this together. Let's actually do it a little bit better. So let's make, now this is fine. So we'll do it like this, and then we're gonna return here the location. So now we're gonna get a random unit vector that is 500 units away from the unit. And let's just start by calling spawn actor from class. We're going to spawn our bomb here, and we are going to call our get complex bomb location, and we're going to use the location that we get from that in here, like so. And yeah, so the logic is now going to be, we start on event begin play. So every 0.2 seconds, it's going to loop, and it's going to call the event spawn bomb. The first thing it does, it calls the get complex bomb location logic, and this is going to be the heavy logic that we want to move over to C++. So if we just take a look at that, so I double clicked on it, it gets the actor location, it generates a random unit vector, multiplies the random unit vector with a value, 500 on all axes, adds this together, and then returns it. And then we go back here to the graph. We use this gets cast into a transform, and we spawn the bomb actor. So just to finish the setup, we're going to go into the bomb actor, and here we're going to go in and on begin play, let's say spawn emitter attached, and let's attach the emitter to the scene root. So that means that this emitter is going to get spawned at the root of the scene. We're going to spawn the explosion. I have this explosion here because because I'm using the starter content, and that's it. So let's see what happens if we play this now. So I've created a new level. I'm just going to add my bomb dispatcher here in the world, and now we can see that we're getting a sphere of bombs. But I don't want this to. I only want the bombs to be. I want the bombs to be level with the with this here. Yeah, level with the actor. So I'm gonna take the. I'm gonna split the vector. So we're gonna get the x value and the y value, and then we are going to do a break. We're gonna get. Let's do it prettier. Let's break the actor location here. And we're going to just use the z value of the actor location. So all of the bombs are going to be now spawned at the same location as the. We can even go in, and if we add a plane, let's add a tiny cube. So we add a cube here just so that we see where it is. Let's call this 0.01, 0.01, 0.01, just so that we see it in the world. And now that we play, we can see that it's here, and all of these bombs are being spawned level to it. So I can even go into simulate mode, and I can move it around a bit. So if we put it here on the ground, now all of the explosions are happening on the ground. Right. So this is the setup. So let's move over to the moving this over to C++. So we're going to imagine that our function, the calculate get complex bomb location function, is a really heavy function, and we wanna move it over to C++ for whatever reason. So let's take a look at the steps that are required to do that. So first we go to tools here at the top, and we do new C++ class. We're going to add a parent class in C++ where we can implement logic for our bomb dispatcher. So I'm going to pick actor because this is an actor. I'm going to give it the name bomb dispatcher. So the name, this is just going to be the name of the file. It is also going to give us the name of the class, but this doesn't really have to be bomb dispatcher. The names don't have to match, but it's nice to have them matching. And one of the conventions that I try to keep is that you see that I have BP underscore bomb dispatcher, and then I have the base class in C as a bomb dispatcher one. Okay, so do create, and we add it to the project. So while this is created, let's take a look at. It should open up Visual Studio for us. Here we go. Okay, so the new class has been created. So let's open up Visual Studio. Yep, we're going to reload it. So this is what we should be seeing. So now you can see that we have a new class. It's called bomb dispatcher, and it's actually two files if I spread this out a little bit in Visual Studio. So we have the CPP file. This is where the logic is implemented, and then we have the header file, or the H file, and this is where we put our definitions and things like that. Okay, so now let's go back to Unreal, and let's take a look at just basically the first step. How do we associate this blueprint? How do we make the blueprint kind of be connected to our newly created C class? So we do that by opening up the blueprint here. We go to class settings here at the top, and here you can see that the parent class is set to actor. If we go back to Visual Studio, we can see that our the actor that we already have, the actor that we made in C++, it inherits from actor. So the definition of the actor of our class here is here, and this line here means that this inherits from actor. So the point of that is that if we go back to the blueprints, we can easily go and we can reparent it. So the current parent of is actor, and we can just say we want your parent to be bomb dispatcher. You can see there was a little bit of a refresh, but nothing really happened. So now we're actually ready to start migrating the kind of the logic over. So first thing that I'm going to do is I'm going to rename the function here to BP get complex bomb location, and I'm going to do that so that we don't run into a naming conflict when we recreate the function in C++. So I'm also going to copy the name here, and let's go over to this here. Oh, I was in the right spot. There we go. All right. So the first thing that we want to do is we want to make the function. So just like in the blueprints, when we press the button here, create new function, and we get a new function here, we can do this in C++ as well. I'll do it like this here. And the way that we do that is here in the definitions, into the header file, under public, you can see that when I created the class, we got a couple of things for free. We got the constructor, which is kind of logic that runs before everything else. It's something that assembles the object. We have the begin play function. So just like in blueprints, we can add logic here to begin play. And we have the tick function, which is the same as in blueprints. We can do stuff on tick, but we want to make a new one. So here we add it just at the bottom of the file, but it's important that it's under this public section here. So we're going to say that our function is going to return. The first thing that we need to decide is what does our function return, and we're going to say it's an f vector. So the f vector is the same as the yellow line or the yellow variable in Unreal. So we say our function is going to be returning an f vector. So we first say what it's going to return, then we say it's the name of the function, and then we do open and close parentheses and this symbol here that I can never remember the name of, semicolon, or yeah. All right, so now we've kind of defined our function, but and normally in C++, if you were just working in a regular C++ program, this would be enough. But because we're in Unreal, we need to add something on top of it as well. We need to mark it as a U function, and we need to add a couple of kind of settings to it, or parameters. And the one that we're going to add is blueprint callable. And this means that the function is going to be available and callable in blueprints. If we don't add blueprint callable to this, we're not going to be able to use the function. And then we need to, so now we've just added the definition to the function. And if we were to compile our project, we're not gonna see anything, and we're probably going to get an error. So we need to add an implementation for this function. And we do that, we can just copy, if we just look at the pattern here, we have to add the return kind of type. So f vector, we add the name of the class. It's a bomb dispatcher, and the A means that it's an actor, and bomb dispatcher is the class name. We do double semicolons or colons, sure. And we add the name of the function, open, close. These are the input parameters if we had any, and then we do open and close curly brackets. And now the only thing that we have to do is it expects us to return a function. It expects us to return a vector. So we'll do f vector result. So it's going to return this. So now we've just created an f vector with nothing in it, and we'll do return result, and that's it. So now if we go back to Unreal Engine, and we compile, nothing is going to happen. We don't have access to this yet, because now that we've added C++ code, we need to compile our code. And the way we do that is, just want to make sure that you can see it. So if I move a little bit, there's a button here that's really nice to use. Oh, that's not good. Called a recompile and reload C++ code on the fly. It's a little button here on the bottom left. You can do this through Visual Studio if you want, but this is pretty powerful. So you press the button. Now it's going to go in and it's going to compile our code and reload the editor, and we can see that we got a little green box here saying that this was correct. Now we can go in here into our bomb dispatcher blueprint. We can see here at the top right that that it is inherited from our bomb dispatcher. And even if I if I'd run this through Visual Studio, I can click on it and go into it. But now if we go to our begin play here and we have the BP get complex bomb location, I can right click here and do get complex bomb location. And now you can see that I have a function here available, get complex bomb location. And this is the function that's coming from C++. Right now it doesn't do anything. We haven't moved any of the logic over to it yet. So let's start moving the logic over. So looking at the logic that we need to move over to C++, it's not very complex, but I just want to show how we actually move some of this stuff over, and then we can take a look at more things that we can do. So if I just minimize this and take a look, so the first thing that we want to do is we want to get an actor location and we want to get a random unit vector. So let's just start filling out our get complex bomb location function with this logic. So the first thing that we want to do is we need to get the random unit vector, and by Googling that, the way that this is done is let's see, we need to create a random stream. So you can see here that the random stream here, like this is an implementation to get random numbers, and this I created an instance of this called random, called rand, and then what I can do is I can call rand.get unit vector here. So this is going to give me a random unit vector. So if I do f vector random unit vector equals, now this is the code that is needed for me to get the random unit vector. So now I've created the same logic as we have here, random unit vector, and it gives me the a random vector with a length of 1. Like this is how that's done in C++. We are going to take a look. So we have the actor location, and here we go. So we multiply the random unit vector with a constant. So we did 500 here. Now it would be kind of cool to have this as a variable. So what we want to do is we want to create something called the random location at a distance. So we're going to get, now we have a vector with 0 to 1, and in the blueprint, what we did, we multiplied this by 500. So we're going to do the same thing. We're going to save this into a variable. We're going to get the random unit vector, and we're going to multiply it by, we can do 500 here. So now we've gotten the same logic. But another cool thing would be to have this as a variable for the user. So the way to do that is here in the header file is we can create the distance variable. So this could be this would actually be a float. I think it's done like this. So let's create a float and let's call it distance from center. And let's give it a default value of 500. And here we need to do the same thing as we did with the function. We do u property, because this is a property. We do blueprint read write, and we do edit anywhere. So this means that the blueprints can read and write into this property or this variable, and this can be edited anywhere. You can edit this in on an instance of the object or in an editor or something like that. So now, since we added this here into our into the header file, we can use this variable in our implementation here. So now I can just say the random location at a distance here is the random unit vector times distance from the center, and we're still just returning the 0 results or the non-result because we haven't started using this yet. But now we've moved this logic here over to C++. And now the only thing that's left is we want to zero out the Z property. So we go in here and we say we want result to be the random location at a distance. And we can say result.z, which is the z value, equals now one thing that we forgot to do. We want to take the random location at a distance, and we want to do the result equals get actor location. So we get the location of the actor, and we multiply. No, we add the location of the actor to the random location at a distance. So this is the multiply that we're doing here. This node basically here. All right. So and just to finish it off, we wanted to return the result with the z value of our result being the value of the actor instead of the value of the unit vector. So, and the way we do that is we do result.z equals get actor location.z. And we need to spell this correctly. And this one here as well. All right, so now you can see that I've modified the result value here. So the z value of the result is the same as the z value of the actor location, and then we return the result. So this should, if we did everything correctly, this should result in the same logic as we had before. So if we go back here into our set event, timer event, let's try it with the blueprints first and see what happens. Okay, so this is working the way that we expected. Let's switch our function out, take the blueprint function out, and we move it here. We can reuse this. And this should give us the same. Yeah, right. So right now, one of the things that's happening is we forgot to compile. So here at the bottom, under my body, we need to press recompile. And that's going to recompile our C++ code just so that it's usable. There is a way to turn on auto compile anytime that the function changes, anytime the code changes, but I like to do it explicitly. Okay, so there is something wrong, and because we're just getting the this information, like it's just being spawned in a single location, and that's fine. So here I'm gonna debug this. It's probably something very, very simple. I'm going to show you what you can do. One of the cooler things that you can do with C++. You can do this with blueprints as well, but the way that I would work now is I would start adding kind of debug information into my actor here. So let's start by adding another property here. So the goal here is debugging debugging this bug and try to visualize a little bit what we're doing. So I'm going to add a new U property. I'm just going to copy this here. This is going to be the same, and I'm going to the one other thing, I'm going to do a category debug, and I'm going to do a boolean, and this is going to be show debug points, and I'm going to initialize this as false at the beginning. Here we go. All right, so we have some logic here that's not doing what we want. Basically the first thing that we want to see is, so we're generating this random unit vector. Let's try to see where that is. So if we do if show debug points here, we can do there's a function called draw debug point here, and this takes in a whole bunch of kind of function, a whole bunch of parameters, and I can just go and start filling them out. So it takes in a world, so I can call get world. it takes in a position. So now I'm going to use the random unit vector position because I want to see where that is, what's happening there. It takes in a size, so let's just give it a 10. It takes in a color, and color can be so you can see that it's asking for an F color, which means that this is a special kind of type of kind of color structure. So we do F color and do double semicolons, and we can do blue. This gives us the color blue, and we say persisted lines, we say true, and everything else we can just leave at default. So to make this a little bit more readable, I'm gonna do it like this. Move. So it needs to be like this. Yep, like this, and then like this, and like this, and then we add a this colon thing here at the bottom. All right. So if we say show debug points, if the flag show debug points is set, we're going to draw a debug point here, and maybe that's going to help us see what's wrong. We compile. So the thing to notice here is we added, if I go into my scene here, you can see I have the BP bomb dispatcher actor selected here. Now here in the details panel, if I move the details panel over a bit, we should see a new, we can see here that we have the bomb dispatcher properties here. This is distance from the center, 500, but we also have this debug one now, and we can turn the debug rendering on and off any way we like. So I'm just going to start. We can see that it's exploding here. I have the bomb dispatcher kind of on. Okay, so I just noticed that the bombs are not disappearing, so that's something that I forgot to do. So I'm going into the bomb blueprint. I'm going to go and look at lifetime, and I'm just going to say that the bombs are only supposed to live for 1 second, so we don't, if we run this for too long. Okay, so back to the bomb dispatcher here. So if I turn on show debug points, you can see that everything is, so it's drawing these points, all of them just here at the at the center of the world at 0, 0, 0, which means that our function here, get unit vector, is not returning anything other than 0 every time. We can also let's just do that. We can also print the lot. We can do a print, and that's done by, let me see, really quickly, and adding a, yeah, so I always have to Google this. Really quickly add in the default logging command here. Here we go. So we are drawing the debug points here, but it would also be nice to know the location of the point is semicolon, and then we do percentage %s, and we do random, move this below like so. So I usually just Google the ulog command or function, and we're gonna say random unit vector to string. So a lot of these things that I'm doing, like the star here and all of this is just something that you just need to pick up on and learn, and it takes a little bit of time. But I just wanted to show the process a little bit on how I would do this. Okay, so now we have a log statement here. It's going to give us a warning, and it's going to tell us the location of each point here. Okay, cool. So let's go back into Unreal and see if this plays. We're going to go ahead and compile our code, and that takes only a few seconds. So now that I play this, I'm going to turn on the, I don't have to turn on the show debug points because we are getting, yeah, so here we can see that our location of the point is the same thing every time. So there's something wrong with the random generation. And what we can do is, we can go in here and we can call generate new seed. And this is actually something that I forgot to do earlier. So generate new seed basically initializes the random generation objects, if I understand it correctly. So let's recompile. And let's see what happens now. Okay, so now we're getting something cool. Something cool is happening. The bombs are appearing in the right location. We can see here on the right that the lifetime that I added is doing its correct thing. And the values that we're seeing here are just really, really small, because this is the logic of this is the unit vector. These are the points of the unit vector. They haven't been scaled up. So let's go back into Unreal. So let's move. We should have done this earlier. Let's move the log into the debug points here. So now we have draw debug points here, and we can continue while we're just building a tool around this that it's just going to help us visualize and make the function exactly work the way that we want it. So I'm going to go and I'm going to take the if show debug points here as well. And I'm going to just add the draw debug points logic in here again. Let's change the color to red. And instead of drawing the unit points, we're going to draw the result. Here we go. So now if we go in, and this is not supposed to be here. Now if we go in and recompile, we have now moved, if I clear this here, so you can see that the logic is working the way that we wanted it. But we also have this really, really nice button here, or this flag here, that lets us see the debug points that are being spawned. So now we get a red dot anytime there is an explosion, and we're also rendering out the unit graph here. So yeah, you can see the kind of the distribution of the points here, and we've also taken a look at how I guess a good way to end this would be to go ahead and delete the blueprint implementation of the function, because now we've actually gone ahead and we've created the we've moved our function over to C++, and we've added some more. We've extended the function to be kind of more flexible and things like that. The only thing that I wanted to double check here is if we run it here, we turn on the debug points and we change the distance from center to 2500. Now you can see that the points are being generated here further away, and yeah. So that kind of concludes it. If you enjoyed this, I love for you to subscribe or leave a comment if there's something that could have done better, or if you know if it's called a semicolon or a colon or whatever it's called. But anyway, thank you. It's been fun.